Okay, so this is number 9, and number 9 reads, two forces, F1 and F2, act on a 5-kilogram object, and the object is represented by this orange ball. And taking taking F1 equal to 20 newtons and F2 equal to 15 newtons when the accelerations in A and B of figure 5.9. So starting off with A, we see that the angle between these two forces is 90 degrees. So they give us F1 and F2, F1 equaling 20 newtons and F2 equaling 15 newtons. To find the resultant force, to find the resultant force, all we're going to be doing is can do Pythagorean theorem with these forces, since the angle is 90 degrees. So to find the resultant force, you do square root of F1 squared plus F2 squared. And F1 is equal to 20 newtons. So we have 20 newtons squared plus 15 newtons squared, and doing that should give you 25 newtons. And we know that force is equal to mass times acceleration. So setting acceleration, or isolating acceleration, should give you force over mass, which is equal to 20, and force is equal to 25 newtons. Mass is 5 kilograms, and they give you that in the problem. So you're left with 5.0 meters per second squared. And that's your answer for part A. Okay, so now for part B, they want you to find acceleration as well. And acceleration here will have both an x and y component, and I think the book wants you to write it in vector form. So force 1 does not have a y component, but it does have force 1, it's all in the x direction. So since force 1 is equal to 20 newtons, force 1x, the x component of force 1, will equal 20 newtons as well. And okay, 20.0 newtons, and then the y component of force 1 will equal 0 newtons. And then for force 2, since this angle is 60 degrees, we know that we can find that force 2x will equal force 2 cosine theta, and theta here is 60 degrees. So, and they give us the value of force 2, which is 15 newtons. So 15 newtons times cosine 60 degrees gives us 7.5 newtons, and that's the value of force, x component of force 2, so 7.5. And then the y component of force 2 is equal to force 2, magnitude of force 2, times sine theta, and force 2 is equal to 15 newtons, and theta equal to 60 degrees. We find that force 2y is equal to 12.99 newtons. Okay. So now to find acceleration, we know that the sum of the forces, I'm just going to translate this into like vector form. So we have F1x plus F2x I And then same thing just in the y direction, f1y plus f2y, j, end bracket, and then Newton's units at the end. So adding if you add F1, which is 20 newtons, and F2, 7.5 newtons, we get, it's not working out, sorry. We get I component of force equal to 27.5 and the y component, which is 0 and 12.99, will equal 12.99 in the j direction. So now, since force, sum of the forces is equal to ma, these values, to find acceleration in each direction, we divide both of them by mass, the mass, which is 5 kilograms. So just by mass, which is, here I'll just write, so dividing by mass by, which is 5 kilograms, we got acceleration in the I direction equal to 5.5. 5.5 I plus 12.99 divided by 5. This, the value of the force in the j direction divided by mass equal to 12, it's equal to 2.6. So j and then units at the end, mass, or meters per second squared, sorry. And this right here is your final answer. So we have acceleration resultant equal to 5.5 I plus 2.6 j meters per second squared. Sorry, it's really messy.